Okay, in today's topic, we look at the alternate segment theory, and the learning objective is to find the size of angles in the alternate segment, and these are the keywords we have. But before we embark on this, students need to have covered and understood angles in a circle, cyclic quadrilateral, tangent, and diameter of a circle. These are our previous lesson we did. Okay, now let's look at the keywords. We have a tangent. Look at in a circle, we say that a tangent is a line that touches the circle at a point. So these are what we did last time. Okay, now the chord, we said that a chord is a line that touches the 2 points or the 2 segments of a circle. Divide the circle into 2, but not at the middle. So you have to differentiate between a diameter and a chord. Now at this chord, this part of the chord are what we call the segment. This part of the chord are what we call the segment, and this is the minor segment, while this is the major segment. So this segment and this segment, this one is alternate segment to this, and this alternate segment to this. Okay, now in the same way, from here to here are what we call the arc of the circle. So this is the major arc, while also these are what we call the arc. This is the minor arc of the circle. Okay, now let's note this first before we move ahead. Say that note the angle between a tangent and a chord is equal to the angle at the circumferences of the alternate segment. Now look at this. This line here is a chord, here is a segment. This line here is a chord, here is a segment. So if here is a segment, here is the alternate segment, and if here is a segment, here is the alternate segment. Okay, now look at this angle here. This is the angle at a tangent and a chord, the tangent and the chord. So this angle here at the tangent and the chord is equal to the angle at the circumferences of the alternate segment. So this angle here is equal to this angle here. In the same way, this angle at this point is equal to this angle. You can look at this angle here is the angle that was made at the tangent and the chord. Now look at this chord. So this angle here is equal to the angle that is opposite on the alternate segment. Okay, now let's solve some question under it. In this case, we are asked to find the lettered angle. Now from here, we note that this angle here must be equal to the angle this side. You see that? Because here is a chord and here is a segment. Here is also the big segment, the major segment, which is alternate segment to this segment. So the angle the tangent make with the chord must be equal to the angle the alternate segment make at the circumferences. So in this case, y is equal to 69. So if y is equal to 69, if here is equal to 69, then in the same case, this angle here, this is a chord and this is a segment, while this side is the alternate segment. So the angle it makes at circumference is this here. So this is equal to here. That means that this place also is 65. Z in the same way is 65. So we have obtained x and z. Now for us to find this x, we know that this is a triangle and the sum of a triangle is equal to 180. So we have that to be x plus y plus z is equal to 180, sum of angle of a triangle. Okay, so here we have that x plus y is 69 and z is 65 is equal to 180. So we sum that together. We have what? 69 plus 65. That gives us what? 134. So we have that to be 134 is equal to 180. So subtract 134 from both sides. We have 180 minus 134. So 180 minus 134 will give us what? That will give us 46. So this gives us 46, and this is the value of x. Okay, now let's look at another example. In this case, we are asked to find the letter m, x, and the n. So for us to find that, we know that this is the angle made by the arc and the chord, and this is a segment. This the major segment, and they are alternate. So this angle is alternate to this angle. That means that here also will be 68. So n is equal to 68. In the same way, this angle here will be equal to m. So we don't know that, and since we have that here, this side is equal to this side, that means it is an isosceles triangle. An isosceles triangle, since here is m, here also must be m, which means that the base angle of an isosceles triangle are equal. So m, they are equal. So since we have obtained this, we can have this, that m plus 68 is equal to 180, angle of a triangle. So that gives us that m plus n plus 68 is equal to 180, sum of angle of a triangle. So we have this to be 2m plus 68 is equal to 180. So 2m plus 180, subtract 68 from both sides. That will give us what? We have 2m is equal to, we have 2m is equal to 180 minus 68. So 180 minus 68, that gives us what? 180 minus 68, we have that to be what? 112. So this gives us 112. Divide both sides by 2. M is equal to 112 divided by 2. That will give us what? That gives us 56. So m gives us 56. So since that here is 56, that means that x is equal to what? 56. So that's how we solve the problem. Okay, now we look at this also, this last one. Now for us to find the letter E, y, and the x, there we know that first of all, this angle here must be equal to this angle here. You see that? This angle y must be equal to E. That's the alternate angle. Okay, now for us to find E, we know 40 plus 76 plus E is 180, angle in a triangle. Okay, so that gives us that E plus 76 plus 40 is equal to 180, sum of angle in a triangle. So E plus, if we sum 76 plus 40, that gives us what? 116. So we have 116 is equal to 180. Subtract 116 from both sides. We have 180 minus 116. So check 180 minus 116. Okay, 180 minus 116, that gives us what? 64. So E is what? 64. So since E is 64, that means Y is 64, because this is a chord. Here is the minor segment, here is the major segment, and angle at the circumferences of the alternate segment is equal to the angle at the tangent and the chord. Okay, so E is equal to Y. Therefore, Y also is what? Is 64. Okay, so since here is 64, we can find our Y, and here we say that we are given that this line, this side and this side are equal. So since this side and this side are equal, this angle here, this angle we are looking at is an isosceles triangle. Okay, so since the isosceles triangle here also will be what? 64. It will be Y 64, base angle of isosceles triangle. Therefore, we can have this to be 64 plus 64 plus x is equal to 180, sum of angle in a triangle. So 64 plus 64 will give us 128. 64 plus 64 gives us what? That gives us 128. So we have 128 plus x is equal to 180. Subtract 128 from both sides. We have what? Subtract 128 from both sides. We have 180 minus 128. That gives us what? 52. So x is equal to 52. So that's how we solve the problem. Thanks for listening.